Hello everybody. Today we will continue to study experimental facts which contradicted concepts of classical physics and which eventually resulted in development of quantum mechanics. We will start today with studying of irregularities in atomic spectra. When we considered thermal radiation, we used such a curve which show us distribution of energy over different frequencies or wavelengths. So this was function f of omega t, which corresponds to blackbody radiation. This is a distribution of energy on different frequencies, so we see that the spectrum is continuous. It means that for any frequency we have some energy which is emitted by a body in some small interval d omega around each of omega from 0 and to infinity. This corresponds to radiation of a body which consisted of many atoms, and these atoms were packed very closely in a body. I mean that in neighboring of each of atom there were other atoms, and in this case they interacted all the time, and the result was such a spectrum. If we will try to measure a spectrum from rarefied gases, it means that gases at very low pressure, when each of atom is separated and is not interacting with other atoms, and try to measure spectrum, if we excite somehow these atoms, for example by electric discharge from the gas in some vessel with gas, then we will obtain spectrum which differs dramatically from this spectrum. And this difference here is intensity of light which we measure, and this is again omega. And we will see that this spectrum consists of some separate lines. So this spectrum was continuous, and this is a spectrum which contains some lines, and these lines, which measured with some width because of final resolution of measuring apparatus. So there is some regularities in position of these lines. For example, if we consider hydrogen as a gas which was excited and emit light, then we have some lines. Maybe they are not necessarily of the same height, but what is important is that these lines, the distance between these lines diminishes with increasing of frequency. So in this case, Swiss physicist Balmer discovered that for hydrogen all these frequencies can be represented by a simple formula, and this formula is omega. Due to some reasons it is designated as omega n2, and this omega, all these lines, corresponds to omegas which are described by this formula. where R is some constant which is called Rydberg constant, and n starts from a number by 1 greater than 2. So 3, 4, 5, and so on. This is in the visible, the spectrum is in the visible part of light. A little bit later, it was found that in ultraviolet part of the spectrum, the similar formula describes spectrum, but omega is denoted by n1 and is r1 over 1 squared minus 1 over n squared, and n starts from 2, 3, 4, and so on, integer numbers. In the infrared spectrum, by the way, this line is called, this one is called, these lines altogether are called as a series of lines, and this series is called Balmer's series. This is Balmer series, and this series is called by name of Lyman, and Lyman series next, in infrared part of spectrum, it was found that the formula similar to this formulas is useful, and it represents the same all the lines which are observed, and it is 1 over 3 squared minus 1 over n squared when n starts from 4. This series was called by name of Paschen. Then we see that all these lines, all the series of lines, are represented by simple formulas, and so-called generalized Balmer formula is omega n m is r, and here 1 over m squared minus 1 over n squared, and n always starts by 1 greater than m. You see that from this formula we can easily obtain all the formulas above. So this is so-called generalized Balmer's formula. If we denote T of n as r over n squared, then we can say that this omega n m's are Tm minus T of n. This T are called spectral terms, so all simply terms. Now we see that these formulas were obtained, as I already said, for hydrogen, but actually for other gases or other cases similar results are obtained with this formula, but maybe T of m and T of n, if we have these terms, so any frequency can be expressed as a difference of two terms like this formula predicts. So we can say that all the emitted frequencies can be represented as a combination of spectral terms. This is called a combinational principle by Ritz. So this is Ritz combination principle, that any frequency which is observed in the spectrum can be represented by combination of terms. If we try to understand these regularities which are observed in experiment and are represented by these formulas, from the point of view of classical physics, there are some problems, because from the point of view of classical physics, first of all, as we already mentioned, that since charges in the finite volume should move with acceleration, so they should emit something, but in case we have classical oscillators, so it is not understandable why the frequencies are not proportional to, are regular distributed over frequencies. So we can expect that frequencies should be like omega 0, 2 omega 0, 3 omega 0, and so on, and it is not clear how why they are organized in such a system, which we called series. And by the way, if we tend n for in each of these formulas n to infinity, so we will come to the some omega infinity, which corresponds to the infinity, which corresponds to, when n is very large, so it is just 1 over m squared, and corresponds to the limit of series. Next, we will consider experiment which was made by Frank and Hertz. What was this experiment? They studied dependence of current on voltage in such a system. They had a tube filled with mercury vapor at low pressure, and there was a cathode with heater. Here was anode, and somewhere here there was a grid. Potential between cathode and grid was here was negative, here was positive. And this potential was here positive and here negative. This is positive, this is negative. And they measured current in the system. This is cathode, grid, and anode. And somewhere here there was measurement of current in the system, and when they measure current, so this is measurement of current in the system. And if we draw a potential diagram how potential changes from cathode to anode. What we have, cathode is negative, and when it is heated, due to thermoemission, electrons are emitted from cathode, and they are negative particles, so they move to positive grid. And this potential was large, and actually plus, and here is some plus minus, so on other side, retarding voltage. So if we follow electron, so here is maximum potential energy of electron, and it moves to positive point this, and now near this grid, it has maximum kinetic energy, and with this kinetic energy, it goes through the grid mainly, and then in the this interval between grid and anode, it is it has to overcome this potential in order to reach anode. But as far as this difference of potential is much larger than this one, most of electrons reach anode. If we draw the diagram of energy of electron, here is energy of electron, and we will denote this is cathode, somewhere here is grid, and this is anode. Then potential, so grid is here. So potential energy and anode is here. Changes like this. Here is maximum kinetic energy, and then in this gap between grid and anode, this is retarding voltage. When electrons travel between cathode and grid, they can collide with atoms of mercury, and the result, if this collision is elastic, then as far as mercury atoms are very heavy as compared with electron, we already know that when a very light particle collides with very heavy particle, it can transfer only a small part of its energy to this heavy particle, so it loses only small part of kinetic energy. Then, if the energy which was gained by electron, kinetic energy, when it was accelerated between cathode and grid, then it is enough in order to reach anode. Look, this is much larger than that. So kinetic energy is sufficient in order to reach anode. But what was result of experiment in the voltage? If we change this voltage we will change this. This is this U, and this is I, current, this. And it was found that indeed, initially when we increase voltage, current is increasing because more electrons are traveling through the tube and reach anode. I mean that this is a cloud of electrons, and not all of them reach anode, because some of them can be absorbed on grid or absorbed on tube walls. But the greater is this field, the greater is force applied from the field to electrons, and more of electrons reach anode. So we observe increase of current, more and more electrons reach anode. But surprisingly, at some energy, at some difference potential, which corresponds to some potential energy of electron, kinetic energy of electron, because it already lost some potential energy and obtained kinetic energy, there were some dips in these characteristics. And then it increased again and again some dip, and these dips were regular. This was at 4.9 volt, and this was at 9.8. And this behavior could be only explained if we suppose that atoms of mercury interact at some kinetic energy of electron. Electron interacts with atom non-elastically, so that internal energy of mercury atoms changes, and so when it absorbs some energy from electron, and electron lose some energy and transfers this energy to internal energy to excite mercury atom. So its energy jump is of loss of energy, and so it cannot overcome this retarding potential. Thus, in this case, we see that the current is dropped. The interesting point is that when we continue increasing U, then we go back to increasing current. So it appears that at lower energy than this one, mercury atom cannot absorb energy from electron, and at larger energy than this one, it also cannot absorb the energy of electron. And it looks like if this field is strong enough, so electron can have two collisions and two non-elastic collisions. For example, if in this distance it collided first time somewhere here, then it can gain energy again, and can, if voltage is enough, so it can twice collide with mercury atom. So we have next dip here, and there are also dips at higher energies. What this indicates us about the structure of mercury atom? It indicates us that mercury atom has separate energy levels or separate energy states at which it can absorb energy. So it indicates that the nature of atom is, I would say, not continuous, but an energy which can absorb atom is discrete. So this discrete nature of atom is explains the result which was observed by Frank and Hertz. Now we will consider, now that we have all these problems with understanding of experimental results, discrete spectra, the results of Rutherford experiment with scattering of alpha particles, results of Frank and Hertz experiment, and this created a long-standing problem in physics, and somehow to overcome this problem, Bohr developed a theory of the atom. So we will study now a so-called Bohr theory of atom. Or Bohr's theory of atom. So what was suggested by Bohr? He considered all the possibilities of explanation of the results, which we already know, and he came to the conclusion that it is not possible to describe what is happening in the framework of classical physics. So he made a very, I would say, brave step, and he announced so-called postulates. So now we'll look at Bohr's postulates first. So Bohr's postulates. What are postulates? Postulates are some statements which are considered as not provable by some direct experiment, but the consequences which follows if we assume that something happening as is formulated in these postulates, these consequences agree with observed experiment. So these are some ideas which may be right, and if they are supported by experiments, so we can say that okay, they are right. If not, so we have to say that these postulates are not adequate to experiment. So postulates were formulated in, there are actually two postulates. You can find these postulates in any textbook, so I will just say what they are and will not write down them. The first postulate stated that actually what was idea? Idea was to consider atom like Rutherford model. Rutherford model means that atom has some nucleus, and the idea was that atom is like a planetary system. In the center of planetary system, our planetary system, there is a sun, and planets travel around sun. And in atom, it was assumed that in the center of atom there is a nucleus, heavy nucleus, and electrons travel on closed orbits around nucleus. We remember that this movement in the finite volume should be accompanied by emission of light because of acceleration of electrons. And what was Bohr postulate, the first Bohr postulates? It stated that among the infinite multitude of electron orbits possible from the viewpoint of classical mechanics, only several discrete orbits satisfying some definite conditions are actually realized. And if electron moves on this orbit, it does not emit electromagnetic waves. Also it travels with acceleration. So it stated that, yes, it cannot be objected that it moves with acceleration, but somehow when it moves on some fixed orbit, and these orbits are somehow defined, so not on the distance between atom and electron as a radius of orbit is possible. And and if it moves on such an orbit, somehow it moves without emission of radiation. And the second postulate stated that radiation is emitted or absorbed in the form of quantum of light energy, h omega, as we know, when electron transfers from one stationary stable state to another, so from one orbit to another. And the magnitude of light quantum equals to difference between the energies of the stationary states between which the quantum jump of the electron is performed. It means that h omega is En minus Em. So the existence of discrete levels in atom was already discovered by Frankenhertz in its experiment. And actually these two postulates can somehow explain what was observed in all the experiments which we considered just now. Well, if we have these postulates, we can say that actually, as far as from this it follows that omega is En divided by h minus En divided by h. If we compare this with what we had here, we see that this means that actually each of terms Tn is simply minus En on h. So in this model we see that indeed if electron jumps from one orbit to another orbit, and these orbits have these energies En and Em, so indeed this omega will be observed as we already considered in Balmer series and other series. Now this Bohr theory is partly classical and partly quantum, because it is based on some classical mechanical laws of motion of electron around nucleus in atom. On another hand, it introduces some non-suitable from point of view of classical physics movement without with acceleration without emission of electromagnetic radiation. Well, from this approach, it is from these postulates, it is easy to construct such an atom. Indeed, if we consider Newton equation for movement of electron on some fixed orbit, so if me is mass of electron, then this is acceleration on the movement on circular orbit, and this is equal to the force exerted from nucleus to electron. The force is Coulomb force. Remember, we use K equal to 1 in this part of the physics. So we will not consider this condition, but he derived some condition for angular momentum of electron, and said that angular momentum of electron can change only by jumps, and these jumps should be such that me vr, this is angular momentum, is some integer number of h. If so, we can from this we can obtain that v squared is n squared h squared over me squared r squared, and substituting it here we obtain that me n squared h squared over me squared r squared 1 over r is z e squared over r squared. Now we have r squared cancelled. Here me and square cancelled, from which, look, here we have n, so from which we obtain that Rn is h squared over z e squared me and n squared, where n is 1, 2, 3 and so on. Now we see that from this assumption we have some radiuses of orbits for electrons in atom. And these orbits, radiuses of orbits, are discrete, as was suggested by the first postulate. Now let's look at energy of electron in atom. And if we look at energy, so energy is kinetic energy, and kinetic energy is MeV squared over 2, and potential energy. And potential energy is minus ZE squared over R. Minus because nucleus is positive and the electron is negative, so we obtain minus. Now from this we have from this we have that MeV squared over 2 is ZE squared over 2R. So I used this equation in order to obtain this term. And if we substitute this here, so we have that E is ZE squared over 2R minus ZE squared R, and this is equal to minus ZE squared 2R. Now we can substitute R from here, and then we obtain discrete energy because R is discrete, so energy will be also discrete. And if we substitute this for R, we have that this energy is minus Z squared E in 4 ME 2H squared N squared. In the case we have hydrogen as in Balmer series, then Z is 1 for hydrogen, and we obtain that H omega is minus ME in force 2H squared 1 over N squared minus 1 over M squared. Actually, when we derive omega from this, we will obtain Balmer's formula. Remember that here we have omega as En over H minus Em over H. Here we have En here and Em here. So if this minus will disappear, and so we will obtain omega is ME in force. Sorry, I will go there. Well, here omega is ME in force 2H cube 1 over M squared minus 1 over N squared. That is actually a Balmer formula, and this is Rydberg constant. So we see that Bohr's theory reproduced this all the effects which were observed for hydrogen, and the result is more than satisfactory. And what this formula assumes from the point of view of this model, this is consider that, okay, we have a nucleus and there are orbits around this selected radiuses, and Balmer's series is if we have here the first orbit, the second orbit, the third orbit, somewhere the fourth orbit, and so on. And this means that these transfers are from electron jumps from some higher orbits to the second one, from this one, from that one, and so on. And the point is that while it is orbiting, it does not emit, and when it jumps from orbit to orbit, it emits light, so electromagnetic waves. Well, what can we say about theory of atom constructed in such way, based on Bohr's postulates and what we call Bohr's theory of atom? Indeed, it was a good guess that something is like discrete in energy levels, and this was a good guess, but the result was not so good. That actually only a hydrogen atom was properly described. In other cases, when we tried to reproduce spectra emitted by different elements, it failed, this theory. And from the point of view of philosophical point of view, this theory was not so good, because it was partly classical and partly quantum. So it was not self-sufficient, I would say. And so there was some contradictory, because it was an attempt to combine classical mechanics with quantum mechanics. As we will see later, actual mechanics is pure quantum mechanics, and so now Bohr's theory of atom has only historical interest, but nevertheless we consider it in order to understand how these ideas were discovered and launched about discrete nature of micro objects.